understand them easily after my discussion. Look, conditions for equilibrium. The first one is the resultant force will be 0, or we can say upward the sum of, maybe there will be more than one force working upwards. The sum of, I'm showing you, then you'll understand.
Upward and downward force is 0.
The sum of upward force and the sum of downward forces are Nubrat. Hello, Nubrat. Nubrat is there or she left? Farabi is still here. Okay. So we have the resultant force will be 0, or we can say the sum of upward forces and the sum of the downward forces are equal. This is first condition for equilibrium, and I will show you with diagram, then you'll understand. This one first, right? Then we have the sum of clockwise movement equals the sum of
Anti-clockwise movement.
the sum of NP. Why we are using plural here? Because sometimes it happens two forces are working together, that we have to also get the how many, we have to identify how many moments are working clockwise, then those we have to make the addition, and which are working anti-clockwise we have to take the addition. Okay, so this way we calculate. We are also having one formula to calculate that one. I will show you that one. The sum of clockwise moments equals the sum of anti-clockwise moment. So you finish writing this, and then I am showing you the explanation.
Same. So
Yes.
Yes, sir, we finished, but I can't hear you. I couldn't hear you first for a moment.
So you finish it first writing, and then
Yes, it's finished.
then we will go for explanation with diagrams. Okay. Are you done with writing this? Yeah, you take a snap, please. For this one, you have a snap. Send it to group. Is it done, Anmol?
Sir, it's done.
Yes, sir.
Yeah, please. Okay, then we are going to explanation how it is working, and I also give you the formula. Here you go. Okay. Now, uh, look, I'm giving you one diagram. Hmm. No, this one I'm giving you little bit different example. Like this is a plank, and there is weight of the plank. Huh? Hmm.
Sir, do we need to draw this?
Yeah, wait, not now. Let me finish, then we'll draw. Okay, I'll tell you when you have to draw. So here is no, it is about the first condition. Huh? It is about the first condition of equilibrium. Like this one is a plank, and this plank is having some weight. For example, the weight of the weight of the plank. Yeah, you got again disruption, right?
Yes, sir.
Why? There is reason. It happens only if someone is calling me directly in my mobile phone that time. Okay, so you see here, this plank has some weight. And for example, the weight of this plank is um, F1. Okay, then we have two more forces working upwards. That those are tension force. Here is one, structure here, and this structure is holding this plank in two places. Like here is it is fixed with one rope, and another rope is fixed here. Okay, so we are having tension force both the sides. It's working as F2. This one is F2. Yeah, this one is F2. Writing here F2. It's 2. And this one is F3. So according to the first condition, according to the first condition, you see the resultant force will be 0 or we can say the sum of upward forces and the sum of downward forces are equal. So here downward force is only one. F1 is working downwards and F2, F3 they are working upwards, right?
Yes, sir.
So we are having all the forces balanced, uh, and we can write F1 equals condition 1, huh? Condition 1, that is F1 equals
F2 plus
F2,
F3.
yeah, F3. So it is about the first condition. Okay, is it clear?
Yes, sir.
So if this is happening anywhere, then the object is balanced, is in balanced. Is it clear?
Yes, sir.
So another condition, already got one example, that is uh, we already did that one. We gave the example of one weight and one stone, huh? That is balanced, isn't it? That is actually the example of second condition. So you draw this diagram and write this condition 1. Then I will show you the second condition also. Do it, please. Now you are getting these two conditions separately, and later on in our worksheet you will get some examples where we'll combine both these conditions together.
Conditions.
Yeah, both the conditions togetherly you will get there, inshallah, and we'll get more confidence that you will understand it more. Now you finish it drawing and write this condition 1, please. Huh?
Sir,
Yes, please.
no, sir, I thought I am disconnected.
Yeah. So we have with us how many participants? 7 participants today. And out of 7 participants, we have Nubrat Nazmol. And so we have 6 from class 8. Abdullah is there. Abdullah was late, right, Abdullah?
Yes.
Then Lamisa is from the beginning there. So you should take the notes. Mithila, I'm not getting Mithila today. She is muted for some reasons. Mithila,
Yes, sir, I'm here.
yeah, are you understanding everything, Mithila?
Yes, sir.
Are you writing the notes?
Yes, sir.
What about Tazrila? Hmm?
Sir, I don't know.
Another student is Rumaya Afrin Mishu, isn't it? So she may be in this final term. Did we get her in this final term, Rumaya?
Yes, sir.
Yes, she
One,
comes in some classes.
yeah,
In some
Okay.
classes.
Okay.
three or four plus she did
Okay, you
get.
tell her to come also in physics class. Okay. If she is taking really physics, she has to do class. Otherwise, she will not understand anything. Okay. So, they who want to take physics, you have to attend in class. Without understanding, it's not possible. Only, only having the notes and doing the worksheet is not enough. You should take part in class. Okay, done, everyone. This diagram and condition 1 writing.
Yes, sir.
Hmm? So I can remove it. So
Yes, sir, you can remove it.
Yes, sir.
So now we are having the discussion on a second condition. Already we had one example. Now we'll get this one with the formula. Okay. So we are drawing first. We are drawing with a simple diagram, like this is a plank again. Or it's a playground seesaw. Okay. Playground seesaw. Simply you think of playground seesaw. It is playground seesaw. Then one boy like Anmol and Taki, they are sitting two sides of the seesaw. Anmol, you know about Anmol, right? And you also know about Taki. They don't have equal force, right? So
Yes.
to make this, seesaw balanced, they shouldn't be in same distance, right? One should be closer to the pivot and one should be away from the pivot. So you tell me who will be away from the pivot? Hmm?
Taki.
Taki, yes,
Um,
yes, exactly. So you got it, mashallah. So Taki should be,
What is lol, Anmol?
yeah. So here should be Taki. Here we are writing here. This is Taki. Yeah. Taki is here, and here Taki is sitting, and Anmol is here, right? Close. Huh? Okay. Now here we are giving some examples. Like we are having 0. Like both the sides, we have 1.5 meter. Huh? This length from the pivot. This side is 1.5, and left side also 1.5. So we get here 1 meter. Taki's position and Almol positions maybe 0.7. You think this is 0.7 or 0.8? Okay. So 0.8 meter and this one is 1 meter. Okay. So you label it from uh, here to here. It's not working. Why? Yeah, from here to here is 0.8, and from the position of the pivot till here, Taki's position, it is 1 meter. Huh? So you think of this one. The left side one is F1. This weight is working here. This is F1. This one is F2. And this one is left side one is D1 and right side one is D2. So we write here, label here. This one is D1. D1 equals 0.8 meter, and here D2 equals 1.0 meter. Huh? So this one we have F1 F1, how much? F1, Anmol? What is your weight?
Sir, can I ask a question?
Sure.
It
200.
is out of topic actually. In physics, why do people give like 1.0 meter these things?
Okay, very good question. Awesome. Like 1.0 meter, we give the answer in nearest centimeter. This is called nearest centimeter. That means there might be some value like 1.1 meter, 1.1 meter. That means we have 1 meter, 100 centimeter, and with that another 10 centimeter. So 1.1 meter. Is it clear? Hello.
Okay, sir.
Yes, sir.
Here
Sir, will we write our answers like this?
it's better.
0.0.
It's better to write. It's better to write so that we can have the idea that in nearest centimeter we have any value or not. Okay. So now we have a very good question, Lamisa. I appreciate your question. So F1, we have F1 is how much? Anmol, you did not say. Wait, 200, you said? What you say? What is your
Yes,
weight?
sir.
What is your weight?
Sir.
85.
Hmm?
Huh?
No,
Sir,
Anmol, you
তোমার
say.
ওজন কত?
Hey, you other students, you don't talk. Let him say.
Sir,
What is
71.
71? So it is
এত
700,
মোটা তুমি?
তোমার
700,
চেতে পাচ্ছি।
yeah, 710 Newton, we say. Okay.
আনমোল আমি 65 তোমার থেকে
Okay.
কম
Yeah,
বটকা রে।
Abdullah, focus in learning. No side talking, please. If you can't do good things, you be stop. Okay.
Yes, Abdullah, shut up.
Hmm.
ওকে
Okay. F2. We have to find F2. Okay. Now, conditions for equilibrium. The second condition, we have sum of clockwise moments equals the sum of anti-clockwise moments. We understand the left side one, it is anti-clockwise, creating anti-clockwise moment. That one Anmol is sitting, and Taki, he's sitting that side, is creating clockwise moment. So we also write here is Taki, okay, and here is Anmol, okay. Anmol. So we are having formula. Condition 2. Condition 2. The formula first you write, that is F1 multiplied F1 multiplied B1 equals F2 multiplied B2. Okay. So this condition or this formula will apply for this example. So you have to find F2, right? So F2, if you make subject F2, it will come F1 D1 multiplied F1 multiplied D1
D1
divided by
into
D2.
D2
Divided
D2.
by D2.
Yes.
So this one, if you place all the values here, you see our F1 is 710. You write it there, 710. Then we have D1 0.8.
0.8
Then divided by
1.0
0
1.0
1.
1.0. Then you can understand what is F2. Okay, what is the answer coming?
Sir, 568 Newton.
568 Newton. So it's showing us that the force applied right side, it is 568 Newton, and the mass, if you think, that can be also find that can also be found, that is 56.8 kg, right? 56.8 kg is his mass. So it's done, right?
Yes, sir.
Clockwise and anti-clockwise movement, you understood. Conditions for equilibrium, you understood, and how to apply it, that one also you understood. That's a great feelings. Okay, now we have with us Abdullah. Abdullah is, today I really feeling good that Abdullah is also taking part in class and he is taking part in discussion. That's really awesome. But you should also take the notes, Abdullah. Hello, Abdullah.
Yes, sir. I'm
Please,
taking the notes.
yeah, please take the notes and be regular in class. Huh? Inshallah, you'll do better. You have lots of talent
Yes, sir.
and you have lots of potential, but you should use them in appropriate way. Okay, and then it will bring something good for you, for society and country, inshallah. Then Anmol understood, I think. Then Lamisa, what about you? Have you understood? Hello.
Yes, sir.
Then Adrita also understood, right? Adrita.
Yes, sir. Understood.
Then Mithila. Mithila.
Yes, sir, I understood.
Yeah, great. Then Taki. Taki. It's about Taki, right?
Yes, sir, I
The
understood.
the
Yes,
question
sir.
is about Taki, so there is no scope to not understand, right? And what is your mass actually, Taki?
Sir, 6.
Sir, 42.
42. Okay, so we actually take you more closer, right? Or a bit
Yes.
far? No, no. We should be taking you a little bit far away, like 1.2 meter. Then it will be balanced better, right?
Okay.
Isn't
Yes.
it? Because the distance should be increased if the force is less. Okay, you understood it, right?
Yes, sir.
So thank you everyone, right?
Bye bye, sir.
You all took
Bye
part
bye,
in
sir. Tata,
discussion.
sir. Goodbye.
Okay,
Goodbye.
Allah
Tata.
Hafiz. Best of luck everyone. Huh? Assalamu alaikum.